Welcome to The Explainer. You know those tools we're all using, like ChatGPT and Gemini? Today, we're going to pull back the curtain and see how they actually work.
So it all starts with you, right? You type something into that little chat box. It could be literally anything. A simple question, a complex command, you name it. And then boom, in just a few seconds, you get a response. And it's not just a jumble of words. It's coherent, it's on point, and it really feels like a person wrote it. So what's going on in that tiny little gap, that little pause between you hitting enter and the answer appearing? It feels like magic, for sure. But spoiler alert, it's not. It's actually a pretty fascinating and logical process.
All right, let's follow the data. We're going to trace the exact path your words take from the moment they leave your keyboard, dive deep into the AI's digital brain, and come back out as a complete answer. So we're going from what feels like magic to what's really just math. We're going to peel back the layers of these large language models and show you that what seems like some kind of thinking machine is, well, it's really built on a solid foundation of science, data, and a lot of mathematics.
And you know what's wild? The key to understanding this whole thing is actually hiding in plain sight. It's right there in the name that kicked this whole revolution off, GPT.
Yep, GPT. It stands for Generative Pre-trained Transformer. And each of those words, they tell us a crucial piece of the puzzle. So let's break them down one by one. First up, generative. Generative is pretty straightforward. It means the model creates brand new content. This is totally different from a search engine, which just goes out and finds a web page that someone else already wrote. An LLM builds its answer for you, from scratch. Okay, so if it's creating new sentences, how does it know what to create? That's where the P, pre-trained, comes into play. This model has been fed an absolutely insane amount of text data. I mean, think, a huge chunk of the internet, a library's worth of books, all of it. That's how it learns grammar, facts, and just how we humans talk. And that brings us to the T, transformer. Now this is the secret sauce. It's the core architecture, the engine that makes the whole thing run. It was developed by Google back in 2017, and its superpower is understanding context. This is the heart of the whole operation. All right, now that we know what GPT stands for, let's look at that very first step in the journey. How do our words become numbers? Because before an AI can think, it has to translate our request into the only language it truly speaks, math. So let's say this is your prompt. It's simple enough for us to understand, right? But for a computer, this is just a meaningless string of characters. It doesn't get words, it gets numbers. So step one is called tokenization. The model takes your sentence and just chops it up. It breaks it down into these little pieces or components called tokens. Then, each one of those tokens gets assigned a number. The AI has this giant internal dictionary where every possible token has its own unique ID. So now, the dog chased the cat becomes a sequence of numbers. Now the computer can actually start to work with it. But just having a list of numbers isn't that useful. So this next step is pretty mind-blowing. It's called vector embeddings. It takes each number and turns it into a rich set of coordinates, placing it in this massive multi-dimensional space. Think of it like a giant star map for words, where words with similar meanings, like dog and puppy, end up being close neighbors. It's how the machine captures meaning. Okay, so our words have meaning now, but language is way more than just a list of dictionary definitions, right? It's about how the words fit together. It's all about context. And this next part is how the model really starts to understand. Check this out. The dog chased the cat versus the cat chased the dog. Same exact words, but the meaning is completely different. So how does the model know? It uses something called positional encoding. It's like adding a little tag to each word that says, hey, I'm the first word or I'm the fifth word. That way it never loses track of the order and it knows who is chasing whom. And what about words that mean different things? Take the word bank. He went to the riverbank is one thing, but he went to the financial bank is something else entirely. This is where the transformer's big trick comes in, self-attention. It's a mechanism that lets every single word in the sentence look at every other word. So bank can see river and think, okay, I get what kind of bank we're talking about. It's genius. So we've gone through all this incredibly complex stuff. Tokenization, embeddings, contextual analysis. It sounds super complicated. But what's funny is that after all of that, the model's fundamental job is actually surprisingly simple. It really just boils down to this. The entire massive, complex purpose of an LLM transformer is to predict the very next word. That's it. You can think of it as the most powerful, most sophisticated autocomplete engine ever built. Your prompt, which is now this rich mathematical object, becomes the starting point. It takes the dog chase the cat, and then it runs all the probabilities and asks itself one simple question. Based on everything I've ever read, what is the single most likely word to come next?
It calculates that the most probable next word is a period to end the sentence, so it appends that to the sequence. But it doesn't stop there. It takes that new, slightly longer sequence and does the whole process all over again. It keeps generating one word at a time, adding it and looping until it finally predicts a special end token that tells it, okay, the thought is complete.
And that's the full journey. Your words become tokens, those tokens get meaning, context gets layered on top, and then the model just starts predicting, one word at a time. It's a loop. What feels like magic is really just a clear mathematical path.
This brings us from how these things work to, well, what they're actually doing. If the entire process is just an incredibly complex statistical prediction for the next word in a sequence, does that count as true understanding? Or is it something else entirely? That's the question we'll leave you with.